Namaste, myself Shivanandappa H Doddagoudar. In this video lecture, I am going to take a BSc 5th semester Mathematics paper 3 Statics and Laplace Transforms. In that paper, I am going to discuss some part of that Laplace transforms. Now, this is the session number 38. In this one, I am going to discuss some examples on first shifting property and scaling property. Okay, in the previous class, we have done a first shifting theorem. What is that first shifting theorem? If L of f of t is equal to f of s, then L of e raised to at f of t is f of s minus a. Okay, we will discuss some more examples in this session. Now, here find that L of cos hyperbolic 4t into sin 3t. L of, by definition of hyperbolic functions, cos hyperbolic 4t can be written as e to the power 4t plus e to the power minus 4t divided by 2 into that sin 3t as it is. That divided by 2 we can take it outside. Then that can be written as L of e raised to 4t sin 3t 1 upon 2 times L of e raised to minus 4t sin 3t. 1 by 2 keep it as it is. You know, in these two terms, sin 3t itself is a f of t. L of f of t, that is L of sin 3t, is what it is? 3 divided by s square plus 9. 3 divided by s square plus 1. You know, s square plus 9. You know, L of sin at is a divided by s square plus a square. Using that one, sin 3t Laplace transform is 3 divided by s square plus 9. But in the first term, a is 4. That's why in place of s, you have tried to s minus 4. In the second term, a is minus 4. That's why you have to take you have to replace that s by s plus 4 the whole square. S plus 4 it is. That's why the total answer is 1 by 2 times 3 divided by s minus 4 the whole square plus 9 plus 1 upon 2 3 divided by s plus 4 the whole square plus 9. One more example it is. Find the Laplace transforms of e raised to 3t sin 5t into sin 3t it is. Okay, before that one it is, no doubt it is a multiplication of exponential term is there, e to the power 3t is there here. No doubt we can make use of that first shifting property here only. Now, that's why here L of e raised to 3t sin 5t sin 3t. For that one, first we should calculate L of f of t. Here f of t is sin 5t into sin 3t. Now, L of sin 5t into sin 3t is equal to L of 1 by 2 times. That means we can make use of sin A cos sin B formula. Sorry, sin A sin B formula. What is that sin A sin B formula here? 1 by 2 times what it is? Cos of 5t plus 3t minus cos of 5t minus 3t. It is minus negative because sin A sin B is minus 1 by 2 times cos A plus B minus cos A minus B. Using that one it is. After simplification, we are getting minus 1 by 2 times L of cos 8t minus cos 2t. Now, the Laplace transformation of that one is that minus 1 by 2 keep it as it is, s divided by s square plus 64 minus s divided by s square plus 4. By taking the LCM, we can simplify that one. We are getting 30s divided by what it is, s square plus 64 into s square plus 4. Now, the replace this s by s minus 3 because multiplication of e raised to minus 3t is there here. That's why L of e raised to 3t sin 5t into sin 3t can be written as 30 times s minus 3 divided by s minus 3 the whole square plus 64, s minus 3 the whole square plus 4. If you simplify that one, 30 into s minus 3 as it is, in the denominator s square plus 6s, s square minus 6s plus 13 into bracket s square minus 6s plus 73 we are getting there it is. One more example here. Find the Laplace transform of t raised to 5 e raised to 4t cos hyperbolic 3t. Here in this case, now we can make use of definition of cos hyperbolic 3t first. Afterwards, we can calculate that, we can make use of that first shifting property. Here, e to the power 4t into cos hyperbolic 3t. Keep the t raised to 5 e raised to 4t as it is. Cos hyperbolic 3t can be written as e to the power 3t plus e to the power minus 3t divided by 2. Then that divided by 2 you can take it outside. T raised to 5 into e raised to 4t into e raised to 3t, nothing but e raised to 7t, plus 1 by 2 times t raised to 5 as it is. E raised to 4t into e raised to minus 4t is e raised to t. Now see this term. In these two terms, again we are having a first shifting property form. That is what exponential term is there, product of exponential term is there here. We can make use of that one is. Okay. In these two terms, f of t is t raised to 5. You know that L of t raised to 5, L of f of t is nothing but L of t raised to 5. That is what it is, 5 factorial divided by s raised to 6 here. You know L of t to the power n is what it is, n factorial divided by s plus s to the power n plus 1. We can make use of that one is. Then by using first shifting property, here in the first term, product of e raised to 7t is there. That means you have to replace s by s minus 7. In the second term, e raised to t is there here. You have to replace s by s minus 1. That's why the total answer is 1 upon 2 into 120 divided by s minus 7 raised to 6 plus 1 upon 2 times 1 into 120 divided by s minus 1 raised to 6. Now, taking that 1 by 20 common, we are getting 60. It is 60 divided by 1, 60 into 1 minus 1 divided by s minus 7 raised to 6 plus 1 divided by s minus 1 raised to 6. That is the answer. Now, one more example here. Find the Laplace transform of this one it is. Okay, you can take that one as f of t. You can expand it using that a plus b whole square formula. We can get like that it is. Now we can write L of that quantity, L of 1 plus 6t e to the power t plus 9t square e to the power 4t. You can use the linearity property. We can write it as a L of 1 plus 6 times L into t e to the power 2t plus 9 times L of t square into e raised to 4t. Now we are getting totally 3 terms. First term directly we can write. In the second and third term, we can make use of that first shifting property. In the second term, f of t is t. Third term, f of t is t square. You know, f of t is what it is, 1 upon s. 1 upon s square. Sorry, 1 upon s square. L of t square is what it is, 2 divided by s cube it is, s cube. In the second term, a is 2. That's why you have to replace s by what it is, s minus 2. In the third term, a is 4. You have to replace s by s minus 4. And write that one is, that answer is 1 upon s plus 6 divided by s minus 2 the whole square plus 18 divided by s minus 4 whole cube it is. Now, these are the examples. Try to solve these examples in the similar way what we have done in the class. Now, the scaling property. What is that scaling property here? Here, if L of f of t is equal to f of s, then L of f of a t it is, a into t it is, a into t. That can be written as f of s minus a divided by a. That means 1 upon a into f of s minus a. Now, we have that by definition, L of f of t is equal to 0 to infinity e raised to minus st into f of t dt. That implies L of f of a t. That means in place of f of t, you have to write f of a t. F of t, you have to write a f of a t it is. Now, we can make use of the substitution. A t is equal to z. That implies dt is equal to dz by a. T equal to 0, z is equal to 0. T equal to infinity, z is equal to infinity. You know that in substitution it is. Therefore, L of f of at is equal to what it is? 0 to infinity e to the power minus s by a into z f of z into dt is dz by a it is. That divided by a we can take it outside and you have to write 0 to infinity f of e to the power minus s by a into z f of z dz it is. Now, this 1 upon a outside and again using the definition of Laplace transforms, that integral can be written as f of s minus s divided by a it is. Now, these are some multiple choice questions. Try to solve these questions and check the correct answer is what it is. These are the references here. Okay. Thank you very much.